So we're starting lesson 4-6, completing the square. Today we're going to learn the basics of completing the square. We're going to work up to and adding that C value when it's missing by completing a square. Tomorrow we'll work more thoroughly with completing the square. So today we're just going to work up to it. We open our lesson with how can you use pieces like these to form a square with a side length of x plus 3 with no overlapping pieces. Show a sketch of your solution. How many of each piece did you need, and explain. So we have one large yellow square block that's x on one side and x on the other. So we can let that represent our x squared. And x, the green one, is x on one side and 1 on the other. So the area of that one would be x, and then the 1 times 1 on the little blue box would be an area of 1. So let's let these represent x squared, x, and 1. Now, when we think about how can we represent this, just with a picture, I have it right here from earlier. So they said x plus 3. So that's 3 of these and 1 of those. So here it is. X plus 3 here and x plus 3 there. Now let's multiply these like a grid. So when we have 1 times 1, that's equal to 1. And now 1 times 1 is 1 here. And then x times 1 is x. Now let me switch my highlighter color so this will show up a little differently. Actually, I'm going to use blue. Okay, so now we're going to go 1 times 1 is 1. 1 times 1 is 1. And x times 1 is x. And continue the process. 1 times x is x. 1 times x is x. And x times x is x squared. Okay, so it's like a multiplication chart in a way. So we have one side being x plus 3, the other side being x plus 3, and when we multiply it together, let's look at what we get. So we're going to have how many x squareds? We have 1x squared plus how many x's? 1, 2, 3, 4, 5, 6. And how many 1s? Well, there's 3, 6, 9. Okay? So if I had x plus 3 times x plus 3, or x plus 3 squared, we know that that's equal to x, this is my a and that's my b, so it's a squared, which is x squared, plus 2 times a times b, so that's going to be 3x times 2, 6x, plus b squared, which is 3 squared, and these match. So there is my pictorial representation of that and proof that it works. Are there any questions about this or how to represent it? Yes?
You were going a bit fast when you were on that part with all those X blocks.
Okay. So let's start over. I'm going to pause the video here. Right, so I'm going to interject. After taking the pause off, I've drawn the equation. It said you need a square with the side length of x plus 3. That means that both sides are x plus 3. How do we represent that with these blocks? Well, I need 3 of the green x's because that represents an x times 1. Well, x times 1, the area of that is just an x. And for the small blue one, it's 1 times 1, so the area of that is 1. And the large yellow block is x times x, which is x squared. So that's what these blocks represent. So to represent x plus 3, I need 1 of the green and 3 of the blue. And here they are. So there's an x plus 3 times an x plus 3. So now let's multiply these out. So 1 times 1 is 1, the center block. Now we're going to go 1 times 1. That's going to be 1 times 1, that's a 1. 1 times 1, 1. And x times 1 is a 1. Sorry, that's an x. I'm getting goofy now. All right. So now let's do it again. And actually it's just a repeat of the previous row. So it's going to be 3 of those and 1 of these. Now for the last one, I'm going to go 1 times x is an x, and 1 times x is another x, and now x times x is my x squared. That's my big yellow block. Agree?
Yeah, I have to remember this now.
Okay, so now, yes, we did this in Algebra 1. In fact, I taught factoring, or started working with multiplying binomials by using these blocks, and I passed everyone out a bag of blocks and gave them several equations to work on, and we did this for a couple of days. So this is just a reminder of, remember when we did this? We're going to be using this now. So they want to get the pictorial, get the picture of what's really happening and why this is what it is in a picture sense. So this is more for our visual learners. So now, how do we prove this works? What do we have here? Well, in the end, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. How many x's do we have? 1, 2, 3, 4, 5, 6, 6 x's, and 1 x squared. So we can say that the area of a square with the side length of x plus 3 is x squared plus 6x plus 9. Now, if you want to prove that, then work it out like we've been doing. X plus 3 squared is equal to, if that's an a and that's my b, it's equal to a squared plus 2ab plus b squared by our rule. And that's a plus b squared. So it's going to be x squared plus 6x plus 9. So this was the pictorial representation, and this proves that we did it right. Are there any questions? Okay. I'm going to pause the video and talk about last night's assignment very quickly. Okay, let's look at the word problem from our assignment last night. It was a short response. It says the area in square meters of a whoops, that's the wrong one. Let me find it again. Here it is. A parabolic jogging path intersects both ends of a street. So let's look at what that would look like. There's a parabolic jogging path. Here's my street. So it's intersecting here and here. Okay. The path, so this parabolic path, has an equation of x squared minus 25x equal 0. If one end of the street is considered to be x equals 0, so we'll call this x equals 0, and the street lies on the x-axis, so here's my x-axis, where else does the path intersect the street? So they want to know, what is this point right here? Okay. So what we have to do is take this equation they gave us, x squared minus 25x equals 0. Apply what we learned yesterday. Okay. So, okay. So, someone just brought to my attention I drew this incorrectly, and I did. So because this is a positive parabola, it would be intersecting this way. So good eye, James. All right, so there we go. All right, so now let's, we learned something yesterday that if we have the zero product property, two things multiplied together, if they equal 0, that means that A is equal to 0 and B is equal to 0, right? So if we can apply that to this, we can solve. Well, right now we don't have that, but we can factor this to be two things, right? What can we factor out of this? An x, and what's left over? An x minus 25 equal 0. So that means that this x is my A, and this x minus 25 in parentheses is my B. So I do have an A times B equals 0. Okay? So now we can solve this. Well, let's look at A first. What makes A equal to 0? What makes the x equal to 0? Well, we just have an x, right? So what makes this 0 when x is equal to 0? So there's our first one, and we already have that. They told us that our first intersection point is at 0. So we're just going to assume actually this is the origin. Let's just make this the y-axis. Okay. So if this is at 0, we've got to figure out what's that point there. But I don't want that to be confused with the parabola, so I'll remove it. All right, so now for our point B, we're going to solve that to get our second point. So x minus 25 equal 0. So what does x have to equal to make this true? 25. So that means that x is equal to 25 for our second point. So that's our answer. And that's all there was to it. Okay? Any questions about that? A lot of students factored this out and worked it with c equals 0, and that would work too. You would still end up with the same answer. Okay? All right. Any questions? All right. Make sure your name and hours on your paper and pass those forward, and we're going to move on to the lesson. Okay, so I'm going to pause. So today's lesson, we're going to learn about formula right here. Completing a perfect square trinomial is what we're going to do today. We're going to take some pre-steps first to get us there. And but by the end of our lesson today, you'll be doing a little bit figure out what number completes this square. And then tomorrow we'll turn it up a couple of notches and take it further. But completing a perfect square trinomial is going to allow you to factor your completed trinomial as a square of a binomial. So you can solve an equation that contains a perfect square by finding the square roots. The simplest of this type of the equation has the form of, and it's right here, ax squared equals c. So the ax squared equals c is what we want to try to get our equations to. In this formula, we're coming from what? Ax squared plus bx plus c. So what's missing in this formula, the ax squared equals c? We're missing a b, right? So if you notice that you don't have an x term, and you just have an x squared and a constant, then we can apply these techniques to it. Okay, so let's take a look at using it. In our first problem, it says, what is the solution of each equation? Solve by finding the square roots. So they give us in A, 4x squared plus 10 equal 46. 4x squared plus 10 equal 46. So we need to get it in that form because we don't have an x term, So we need to get it in the ax squared equals c. So we've got our ax squared right here, right? But we need it to be equal to our c value. So we need to get rid of this. Okay? So subtract 10 from each side. And then we get 4x squared equals 36. Everybody with me there? Now it's in our ax squared equals c. Everybody see that? So our next thing is to start solving for x. So we need to divide each side by 4. And we get x squared equals 9. Now remember from a previous chapter and from pre-algebra and algebra, we've done this 1,000 times. How do you clear that square? Anybody? James?
Square rooted.
Take the square root. So when I take the square root of x squared, these cancel out, right? And it gives me x equal the positive or negative of, and we've got to take the square root of that side, square root of 9. Because what you do to one side, you must do to the other. Now, what is the square root of 9? 3. And so, your answer is x equals the positive and the negative of 3. So that's the same thing as saying x equal a positive 3 and x equal a negative 3. Okay? So that's our answer. X equal positive negative 3. Any questions? All right. Let's move to the next problem. Oh, B. Let's look at B. 3x squared minus 5 equal 25. Okay, so let's take a peek at this one. Again, we're going to have to just solve for x, right? That's all we're doing here. So if you forget the formula, just remember we are solving for x. So just start getting rid of everything and isolate your x. So when we do this, we get a 30 equals 3x squared. Now divide both sides by 3 and you get x squared equal 10. And now take the square root of each side and we're going to get x equal positive negative, and then we can't simplify that any further, just leave it as square root of 10. Someone asked me earlier, why is it positive negative? Well, the positive negative goes with simplifying that, your square root of x squared. And let's think about what this says. If I have x squared equals 25, what can x be equal to make this true? What can I square to get a 25? 5. 5 squared equals 25. Is there any other number I can put in there? A negative 5. So negative 5 squared is also 25. So that's why when you remove the square by taking the square root, your answer is going to be a positive or negative, because it can be both of those, positive and negative. Okay, does everybody see that? So very important, if you leave off the positive negative, you're missing your answer. And that's a very common mistake. And on this ACT test, they put your most common errors as answers. So be careful. Okay, remember those little rules. Any questions on these two problems that I just worked? Pretty easy, right? In this next problem, I'm going to go over this word problem. And this is a really nice problem. In architecture, while designing a house, an architect used windows like the one shown here. What are the dimensions of the window if it has 2,766 square inches of glass? So, what are the dimensions of the window? Well, this whole thing, it means the rectangle at the bottom plus the dome on the top. all of that is 2,766. Now, they gave us a couple of measurements. Across the top of this window, its width is x, and the length or the height of the square window is 2x. So we know that 2x times x is the area of the bottom rectangle, the bottom window here. So 2x squared. But what is the dimensions for this half circle up here? Okay, so that's our little dilemma. So we have to start by taking what we're given. So to find the area of the window, we know, like I said before, the area of the rectangular part is 2x times x, which is 2x squared inches squared. Now the area of the semicircular part, well, what do we know? It's going to be 1/2 the area of a circle. What's the area of a circle? Pi r squared. So it's going to be 1/2 of pi r squared. But what's our radius of this circle? If we have a half a circle, and we know that from here to here it's x, well, the radius must be what? Half of x. So if the area of the circle is 1/2 the area of a circle, pi r squared, and we know the radius of this is just what? 1/2 of x, or x over 2. Replace the radius with x over 2. Okay? So that's how they get this next part. Oh, that's radius squared. So if the radius is x over 2 and we square that, what do we get? X over 2 times x over 2 is x squared times 4. Excuse me, over 4. So there it is right there. So the semicircle is going to be 1/2 pi x squared over 4, or multiplying those together, you've got pi over 8 x squared. Okay, so that's the area of the circle. So if the bottom we said is 2x squared and the half circle is pi over 8x squared, we can now write an equation. 2x squared plus pi over 8x squared is equal to, and they told us by definition, 2,766 inches squared. So now we've got an equation we can work with. And they do have something in common. They have an x squared in common. So we can factor that out. By regrouping, we can rewrite that as 2 plus pi over 8 times x squared is equal to 2,766. Now, do we have an ax squared equals c? Yes, we do. So this is our a, 2 plus pi over 8 x squared equal c. So now we've got all that. So all we have to do is divide each side by our a value, divide each side, and it clears it here, and that's why it's under here, and then take the square root. And when you plug this into a calculator and solve, you've got x is approximately, they've rounded a little bit, equal to positive or negative 34. So that is the length of our x value, 34. So if that's 34, then the dimension of this window has to be 68, right? So the rectangular window is 34 by 68. The semicircular top has a radius of 17 inches. All right, so are there any questions on that one? You just have to work it like a little number puzzle and take what you're given and keep going a step further. And remember, the only formula introduced so far is the ax squared equals c. So all of these problems should be working towards that goal. Remember that when you work your homework. Okay, let's look at problem 3. It says solving a perfect square trinomial equation. So what is the solution of x squared plus 4x plus 4 equal 25. Well, can we get that to look like ax squared plus c? Sure, but I can see that a is going to be equal to 1, right? How can we do that? Well, we can see that this is a perfect square trinomial because it's in the form of a squared plus bx plus c. Excuse me, a squared plus 2ab plus b squared. Sorry. All right, so let me write that out again. A squared plus 2ab plus b squared. That's a perfect square trinomial. So is that a perfect square? Yes, it is. Of what? X. So my x is a. A is x. And is this value a perfect square? Yes, it is. Of what? It's a square. The square root of 4 is 2. So my b is 2. So now multiply them together and double it. 2 times x is 2x. Now double it. So it's going to be 4x. Does it match the middle term? Yes, it does. So this is a perfect square trinomial. So we can rewrite it as a plus b squared. So it's going to be x plus 2 squared. So we're going to rewrite it as x plus 2 squared equal 25. So there's our a, x squared equals c. So my x this time is now an x plus 2. So now all we have to do is to start solving. And whether you remember that formula or not, all we're doing here is solving for x. So once you rewrite and you recognize I can simplify this to that, it becomes a quite easy problem. Takes the square root of each side and you get x plus 2 equal positive or negative 5. Because the square root of this and the square root of that cancels these out. So you get x plus 2 equal, and square root of 25, positive negative 5. Now we're going to solve this two ways. We're going to solve it as x plus 2 equal a positive 5 and x plus 2 equal a negative 5. And when you do that, you're going to get x equals 3 or x equal negative 7. And that's how you work these. Any questions? Let's work another one. So let's get your whiteboards, and I want you to work this on the whiteboard. Let's see if I have it bigger. I do. I've made this a lot bigger for you to see. So x squared minus 14x plus 49 equal 25. So work this quickly. I'm going to give you, see where you're at in 2 minutes. Okay? And begin. I'm going to pause the timer. Okay, row 1, let's see your work. Row 2, whether you're finished or not. Thank you. Row 3. Row 4. Row 5. Row 6. Okay, so I see some of you taking a really long way around this and you're not finishing because of that. What do we see here in our equation? Is that a perfect square trinomial? Is this a perfect square of something? Yes, of x. Is 49 a perfect square of something? Of 7. Now multiply those together, because we've got to get our 2ab. So a times b is x times 7, 7x. Now 2 times it, so double it. 14x. Does that match my middle term? So we've got a perfect square trinomial. That means that we can rewrite this as x, because we've got a negative right there, x minus 7 squared. So you start off by recognizing that and rewriting that trinomial as x minus 7 squared. okay, equal 25. Now, it's a piece of cake from here, right? All we do is take the square root of each side, and that cancels out, and you get x minus 7 equal positive negative, and square root of 25 is 5. Now, you're going to solve it both ways, as x minus 7 equals a positive 5 on the left, and x minus 7 equals a negative 5 on the right. And when you solve, you're going to get x equals a 12 or x equals a 2. And that's our answer. Is there anybody who needs another example? Would anybody like another example? One more? Okay. I'm going to have to pull one from the assignment. Because if I make one up, it may not come out perfectly. Let me pause. So let's look at number 10. This is out of your homework, so just take notes because we don't have enough time. So we've got x squared minus 14x plus 49 equal 81. So is this a perfect square trinomial? Again, it's the same one we just had, right? That it's x minus 7 squared equals 81. Now, we're just solving for x, so we've got to get rid of the square. So take the square root of each side, and that cancels out, and we have x minus 7 equal positive negative, and now the square root of 81 is 9. So now we've got to solve it as a positive 9 and a negative 9. So we're going to have x minus 7 equal positive 9, and x minus 7 equal a negative 9. We've got to solve it both ways. So this one's going to be add 7 to both sides, and you get a 16. So x equals 16. And over here, we're going to add 7 to each side, and you're going to get a 2. So x equal 2. That might have been, that's almost the same problem we worked. All right, is that better? Okay, I've got to move on. We have 4 minutes, and I've got to show you the last problem. All right. Now they're going to give us an equation where it's missing our c term, and we've got to complete the square to finish it. It's called completing the square. And if I had, let's look at this one. Let's look at this, x squared minus 10x. And they say what value completes the square? And your last problem set is just like this. So x squared minus 10x. How do I complete the square? Well, what I have to do is say, well, I'm missing that term. How do I get it? Well, there's a little trick. And it's just divide your middle term, your b term, by 2 and square it. So negative 10 divided by 2 is negative 5, and negative 5 squared is 25. And that's all there is to it. Now I can rewrite this as x minus 5 squared. And that's completing my square. All right? So the first problem in your problem set like this, we've got x squared plus 8x plus, and there's a box there. So again, divide this middle term by 2 and square it. So 8 divided by 2 is 4, and 4 squared is 16. Now we can rewrite this as our perfect square, as our squared binomial. So it's going to be x plus 4 squared. Now, I don't think they have you rewrite it. They just have you fill in the box. But realize that's all this is. Yeah. So divide the middle term by 2 and square it, and that gives you your c term. That's called completing the square. That's as far as we go today. Tomorrow we're going to build on this and learn lots more things about it and how to use it. So your problem set tonight is 4-6, number 1 through 21, work all the evens. 1 through 21, all the evens. Okay? Thank you. And that concludes our lesson.
we're doing 1 through 21 and only evens, then why include the 1 and the 21?
Because some year I may decide to change that to odds.
Okay.
What I do is I look at the problem sets. Where does each problem set take me? Well, the last problem set goes 16 through 21. So I make it through 21, then I decide, do I want them to do all of the problem sets, the evens of the problem sets, or the odds?
Okay.
So that's why. Any other questions? Thank you. This concludes our lesson.